Hello viewers, welcome back. Today's video lecture we are going to talk about the reactions of alkane, especially halogenation of alkane. How the halogenation reactions takes place in the alkane compounds. Before getting into the reaction, we just see the overview of alkane or the nature of alkane. Please remember that the alkane compounds are highly inert compounds. Most of the time it will not undergo any chemical reactions. Please note it, chemical reaction under normal conditions. Please remember that alkanes will not undergo any chemical reactions under normal conditions with any acid, base or any like oxidizing or reducing agents. However, under special circumstances, it will undergo halogenation reactions, especially at higher temperature or at light, the photochemical reactions. Okay, so this is one of the special reaction for the alkane compounds. Now see this overview. Now we took the example of methane and reacting with chlorine in the presence of light, so we are getting the chloromethane. So this is the overview of this reaction. That means overall reaction. Let's see how this reaction takes place. So this reaction takes place under 3 steps: the initiation, propagation and termination. First we see the initiation. In the initiation step, it produces the reactive intermediates. As you know, there are few reactive intermediates, especially that are called a free radical and carbocation, carbanion and carbene, so ylide. So these are few names for the reactive intermediates. Okay, so most of the reactions proceeds through the formation of reactive intermediates. So in this reaction, the halogenation of alkane, so it proceeds through the formation of free radical. So here in the initiation stage, the chlorine molecule undergoes homolytic cleavage. So this we already discussed. If you want to learn more about the homolytic cleavage, so please go through the description link. I posted the video lecture, so please go through it and learn it. Okay, so the chlorine molecule undergoes the homolytic cleavage where it forms a free radical. Now this chlorine radical is more reactive, so this will not be ideal, so it will trigger the reaction with the alkane. Okay, now as soon this chlorine radical has been formed, so it undergoes the propagation step. So we should know what is the meaning of propagation. Propagation means in the chemistry, especially here, that is a regeneration. Every time it will reform it, or it will forming again and again. Here the propagation means here the radical is forming again and again. So that only is mentioning here. So this chlorine radical, once it formed, it will react with the neutral molecule here with the methane. So it created a methyl radical. Okay, So again, this methyl radical will be a reactive species. This methyl radical react with another chlorine molecule by, you see, you have to use very careful. You have to use this single headed arrow. You see, the single headed arrow is for the homolytic cleavage. So this methyl radical again react with this chlorine molecule. It forms a chloromethane. So again, you see, this chlorine radical is getting regenerated. So this is called as a propagation step. Now let's move into the last stage, termination. So here, so we formed two types of a radical. One is chlorine radical, another is a methyl radical. So how this is going to get the terminated? So two chlorine radicals can combine each other, so it form a chlorine molecule that become a neutral molecule. Another way, the methyl radical and the chlorine radical may combine each, so form the methyl chloride, or other way, two methyl radicals may get combined to form a ethane molecule. Now you see, so this overall reaction is called as a free radical substitution reaction. Why we call it the free radical substitution reaction? You take this methane. In this methane, the chlorine molecule is, the chlorine atom is coming in the form of, substituted in the form of radical. So this chlorine came in the form of radical. That's why we call it as a free radical substitution. Suppose if the incoming group came in the form of nucleophile, then we call it as a nucleophilic substitution reaction. If this incoming group came in the form of electrophile, then we call it as an electrophilic substitution reaction. But here this chlorine group came in the form of a radical. That's why we call it as a free radical substitution reaction. Okay, I hope you understand this, how the methane undergoes the halogenation of reaction. Now let us see what will happen if the higher alkane, take an example like ethane or propane, how the ethane will undergo this halogenation reaction or free radical substitution reaction. So the first step is, as usual, that is common, the chlorine radical will get formed. That chlorine radical will create this one, react with this alkane molecule, it forms ethyl radical, you see. So it will generate like this. So this ethyl radical will form, you see. Once this ethyl radical is formed, so it will react with chlorine. So it will take this way, and this chlorine radical gets going like this. So finally you will get like this. The chlorine will get substituted in this. You see, observe it very carefully. So the first step is the chlorine radical generation, thus as we discussed in the methane. So that I not written here. So that chlorine radical react with this ethane, it generate this ethyl radical and it react further. So it formed like this. So I am writing here only the key steps. Okay, I am not writing any the termination or how the radical generated, the chlorine radical generated in the first step. Okay, so this is how it is formed, the ethyl radical. So this chlorine radical, once it formed, it may pick any of this hydrogen atom from any of this carbon. So in either case, if it, suppose this is the first carbon or second carbon, so it will form the radical by here or here, both will be the same. That's why I put it in only one. So finally we get this compound. Let's see what about the propane. Now the propane, once this chlorine radical has been formed, so it may have the option, you see, I am labeling it here. This is first carbon, this is the second carbon, and this is the suppose third carbon. So it may abstract the hydrogen from any of this 3 carbons. Suppose if it is attacked at the first carbons, and what will happen? So here there are possibilities of 3 radicals. Now you see, I am writing like here, CH3, CH2, CH2. So this is the one. If suppose at the first carbon, okay, first carbon. If it is the second carbon, so we will get like this, like this. If it is the third carbon, so I will write here itself, because the third carbon will be the same. You see, if it is the first and third, it looks as a same. So why, in conclusion, we will get only 2 types of radicals, either this one or this one. Only 2 radicals can generate from this propane. Among this, which one will be the major one? So that can be concluded by the bond dissociation energy. Please here you see here. So this is the methane, this is the one ethane, and this is the one the propane, and this is the one a tertiary one. Listen carefully. Now you see, this is the methyl hydrogen. So bond dissociation energy requires to form a radical in this one requires 435 kilojoules per mole. You see, in the primary hydrogen requires 410. At the secondary hydrogen, the radical formation requires 397 kilojoules per mole. But the tertiary hydrogen requires to cleave the radical, okay, that CH bond, to cleave this one, it requires 381. That means the tertiary hydrogens can cleave very easily. So you know that, I hope, what is primary, secondary, tertiary. You see, this carbon is primary because this carbon is connected to only one carbon. You see here, this carbon is connected to a secondary carbon. That's why this is secondary. In this case, this carbon is connected to 3 carbons. That's why it is a tertiary. If that hydrogen is in the tertiary carbon, so we call it as a tertiary hydrogen. I hope you understood it. So when the chlorine radical is formed, to cleave this radical, that carbon hydrogen bond, so this tertiary hydrogen always requires the less energy. Comparatively, this one is little bit higher. But in this case, you see, here it is the primary and this is the secondary. So this is the primary radical and this is the secondary radical. Now this will always occurs in the form of major. So the secondary radical will appear very easily than this primary. That's why, so this one will react with this chlorine molecule. So we will get this product as in major form. But here either of this one, so we will get like this. This is 1 chloropropane and this is 2 chloropropane. So this will always in the major form. Why we get this one as a major form? This is the reason. The first reason I told you, because the bond dissociation energy required for the secondary hydrogen is very less. That's why this will form in the major amount. And the second reason is the stability of the radical. Stability of radical. So here the tertiary radical is more stable than this secondary radical than primary radical, then methyl radical. These are the two reasons. One is the stability of radicals and bond dissociation energy. This is the energy, bond dissociation energy. There the secondary hydrogen requires lesser than the primary, because here we are talking about the propane. Okay, so you can try for this one. I'll give this one of the alkane compound. Now you can try the chlorine molecule in the presence of light. Find out how many isomers are possible for this compound, and among that which is the major. So you can leave it in the comment section. I hope you understand this lecture. Kindly subscribe and share it. Thank you very much.